Hello world, I'm Solve Hard Problemo, and today we're going to solve fourth problem of programming study skills. Programming study set skills problems. And today's problem is valid anagram. So let's get started. So what we have in this problem? We have two strings, S and T, and we have to return true if T is an anagram. What is anagram? Anagram is a word formed by rearranging the letters of the other word using all letters from the parent word exactly once. So it means that we can build. Actually, it says that T is almost it's exactly the same as S, but just rearranging the letters at any possible position. So, and yes, we return true if we can do it. If we cannot do it, we return false. Probably not so tricky at the first sight. So, what questions might appear here? To it, what constraints tell us? So basically, we have two constraints here. That's why this problem is easy one. So the length of the given strings is between 1 and 5 to 4, which means it's 50,000 possible characters, and the strings cannot be empty. And S and T consists of lowercase English letters and only lowercase English letters, which means we can use a 26 size frequency array. And the second possible question is that come up here is the follow-up. What if the inputs contain Unicode characters instead of just a lowercase English letters, and how would you adapt your solution to such case? So this solution to this problem, I will today I will deeply cover this solution, but it will be in the end. So we will cover the main ones. So actually, as I do usually, when I solve such problems, Leetcode problems, I try to imagine something as thinking what this problem might be in a real world case scenario. And here, the story is such that a factory recipe says a batch must include certain ingredient tokens. So it means that we have just probably a recipe in a factory, and during mixing, order doesn't matter, and ingredients can be added in any order, but the exact count matters. So did we add the same ingredients in the same amounts? So if yes, this is exactly the anagram, and everything is good as it's same letters, same counts. So for example, a recipe card says we have A, B, C, so 2 units of A as tomato, for example, I don't know, 1 unit of B as cucumber, and 1 unit of C as pepper, for example, I don't know. And actual batch log is CABA, so it means that all ingredients are in this recipe, we are good, and our shopping list is probably covered. So in a shopping list, when we go to the store and we have to bring some ingredients, when we take everything, count, position, putting items in the cart doesn't matter, but counts must match. So this is it. This is a real world case scenario, and this is the way. And for this problem, we have two possible solutions, which is probably sorting and counting letters. For the sorting, this is the solution. So for the sorting one, probably we just go through each of the string and we sort them. And then they will become probably the same. So here the example, we have anagram, and while we will sort it, we will have probably the same, not probably exactly the same string, and this is anagram. This is how sorting solution works. And what we have to do, we will just check lengths, we'll sort both strings and compare them, and if they are equal, so it means that this is anagram, and we will output true. And if not, it's false. Probably really easy. And complexity of this solution would be O n log n, because sorting takes about on n log n. And in Python, space would be on, because sorting both strings would allocate some new list of length n. So that's why we will have on and on log n for time and space on. Probably this is it for sorting solution, but we need a little bit better solution, because our constraints is up to 50,000 characters, possible characters in strings. That's why we have to deal with a little bit better solution, which is counting letters. So counting letters, how it works, we just have us to make as we have two strings, and if each letter of this string appears the same number of times in both, it means it's anagrams. And we could use we could create a list of 26 zeros and count how many times each of this letter appears in the list, and we will just count every possible variations. For example, if C will be AACC and T will be CCAA, so we will just count S, and by counting in the list, we'll have, for example, A appeared once, we will increment it by 1, and if, for example, we see A one more time, we will also increment it, and A will have 2 times. C, for example, also 2 times. And then after counting number of characters in S, we will just subtract then number of characters in T. So, and when we will subtract it, when, for example, we see C here, we subtract 1, so decrementing by 1, and do the same. And it will back to 0, and if all brackets will be 0, means that in the end, in the list, we have all zeros, and it's true. It means that this is an anagram. And complexity of the solution is on. We'll scan S and T once, this one, and space would be O1, because 26 buckets is always constant. That's the solutions for this question. Probably everyone could do it, and everyone could just think about these solutions. It's not so tricky problem. But today we will cover another part. We'll cover follow-up, which means so we'll answer to this question. What is it? It says that what if the inputs contain Unicode characters? So as we did before, our fast counting solution used only lowercase English letters, and so we could map from A to Z. And with Unicode, there are way more than 26 possible characters, possibly thousands. So it means we will cover emojis, Cyrillic letters, Arabic letters, and all of the other things. So we can't use a fixed 26 size array, and we can't safely do this function and just do this function. Sorry. Instead of 26 buckets, we can use a dictionary, which means dictionary is just a key and value pairs. So key will have the character itself, and value will store as frequency count, how many times each letter appeared in each of this string. So what we have to do, we have to first, of course, check the length, then we would have built a dictionary of counts. For example, here S is A emoji in A, so we will see A, and we will store value as frequency, which is 1. Then we will go through this emoji, frequency would also be 1. Then when it comes to A, again, we'll have a frequency of 2. And this will be our final dictionary, with A appeared twice and emoji once. Then we will subtract counts using T, so we come up here, and we see the emoji that is the same, so frequency becomes 0, and we will delete this because we don't need it. So here, if in T we also appear this, in dictionary we'll just delete the emoji, we don't need it anymore, so it will be more efficient and more optimized solution, I think. And then we do the same with this, and if all letters cancel perfectly, dictionary is empty. But here comes one problem, which is in Unicode, same looking characters might not be equal. For example, here's the example of letter E with the accent. For example, it can be stored in different ways. First, one single character, as this is probably the code for this letter, and two characters that look the same. For example, we can have E plus combining accent. So this becomes really different from what we have here. And when you print both, they look the same, probably, but inside the computer, they are different sequences. So why this is the case? Because Unicode supports combining marks, so the accents probably. So it can represent many writing systems flexibly. So for example, imagine if S would be like E accent A, and T would be A plus this just E plus combining accent. So they look probably the same, but direct character by character count would say they're different, unless we normalize it. So normalization means convert text into a standard form so that equivalent characters use the same representation. What it means. So what we will use is NVC. It's probably you can think of what is NVC, but don't bother yourself. Don't think about this. NVC is just a normalization from C, and I also not pay attention more into details. Just make sure that we have NVC. And what it does, it just normalizes this probably this case. So if we'll have E plus this code and the common accent here, combining accent and E. In this case, we'll just normalize it to this view. So it would be probably the same. Now let's go to the solution itself. So here we go. So this is it for today. See you tomorrow.